Okay. So we are continuing from where we left. We're talking about classification of organic compounds. We said they're classified into homologous series, and each homologous series is having a specific functional group. At the same time, we can have two or more functional groups at the same compound. So some of these compounds includes the alkanes, which are traditionally known to be having a single bond, and a very good example is butene with 4 carbons. We are going to look into how do we reach into those structural formulas, as you can see. Okay, so the next one is an alkene, which is single as well and characterized by a double bond there, as you can see. So remember, there's actually a clear difference between alkanes and alkenes. Alkanes, they are saturated. Alkenes, they are unsaturated. Saturated being that they can no longer, in fact, they do not have a free bonding point. Okay, they do not have free electrons for bonding because all the 4 electrons are included in a bond. But here on the double bond on alkenes, there is an electron cloud inenge iri pa double bond, as you right here. There is an electron cloud in between the carbon atoms there. So we say it is unsaturated. Okay, a very good example is propene with 3 carbons on the chain. So these double bonds and single bonds are considered only along the carbon to carbon chain. Okay, another group is the arene, which now we refer to as the benzene ring. So basically, the arene is a 6-cornered ring, and inside the ring there is a pool of delocalized electrons. There is actually a pool of electrons packed up. That's why there is that internal circle there. So the arene, pakona pega panenge paine carbon. On every corner of that benzene ring, there is a certain carbon. Like, let's take for example, this is the first corner, and the so as you can see, kunobva kwaita imwe chi, kunobva kwaita imwe carbon, kuno kwaita imwe carbon. But tiri kuti ipapa this carbon yatatanga kudrowa iyi must be having, we mean this carbon must be having 4 bonds. So already it is bonded to two other carbons. So yasara ne 2 bonds. Kunobva yaita imwe bond kuno kubva kwachi hydrogen, right? And then after that, we are going to see that here now there is actually going to be another delocalized electron, which is going to be supplied to the pool of electrons. Okay, so as you can see, if you are to continue with this diagram, we are going to see that panapa paita futichi another bond, and then another carbon here, zvidaro. So the ring goes on and on. So at every point where there is that ring, at every corner of the ring, there is actually a carbon which is there, and that carbon is bonded to 2 other carbons and a single hydrogen, and the other bond rech4 racho rinenge riri unbonded. So we also have the halogenoalkane. So you know halogens, they are group 7 elements. So a combination of a single group 7 element to a carbon in a certain hydrocarbon is what we call a halogenoalkane. As you can see there is a C for carbon, but carbon iyo yatiri kuona iyo iri pazasi, we mean carbon iri panapa ishi yandavhara neichi chanditika, that carbon inenge ine 3 more other bonds dzinenge dziri dzehydrogen, and then X uyo ari kumiririra either chlorine, bromine or iodine, whichever halogen ichabonda, as you